Alright guys, so welcome to this live. I am wanting to actually start a section here, a lesson on this topic, calculus. Okay, yeah. Calculus is basically divided into two branches. There is what we call differential calculus, and then there is what we call integral. Okay, so here, this kind of calculus, this is the calculus that they do in varsity first year. Okay, this is the calculus they do varsity first year, and this is the calculus that they do in matric. All right, so students join, or students do differential calculus, and when they do it, it seems like sometimes the understanding is not there, or at least they have a pretty good idea of some of the things that are done there, but they don't have a very solid idea. Okay, so we are going to do this calculus, but this one we are not going to do because, as I said, I specifically focus on high school mathematics and not varsity maths. So you're not going to hear me speak about integration, okay? Though I did it when I was studying for my degree, but I'm not going to do it. This is the calculus we are going to be focusing on, okay? Yeah, so I just want us for a moment to consider the following. I want us to consider a function. Now, by now, you guys should know what a function is. A function is basically a relationship. It's the relationship that exists between x and y, right? Your input and your output value. It is either, a function can either be 1 to 1, or a function can be many to 1. That is in essence what defines a function. A function can be 1 to 1 or many to 1. So let us consider for a moment the following function. Okay. The function f of x is equal to x squared plus 4x minus 12 over x plus 6. All right. Now let us simplify this function, which means, in other words, we are going to simplify this expression. If we simplify that expression, x squared plus 4x minus 12 over x plus 6, what do we get when we simplify the expression? So of course, this is a division of a trinomial over a binomial. So when we are simplifying a trinomial over a binomial, do you guys remember in grade 10 how you went about simplifying a trinomial over a binomial? What would you do to the numerator to the numerator that consists of 3 terms? If you want to simplify the expression, what would you do? X squared plus 4x minus 12 needs to be factorized. So if we factorize x squared plus 4x minus 12, this is a quadratic trinomial that has a constant term that is negative 12. So when you factorize x squared plus 4x minus 12, you know that you are going to open 2 brackets. Factors of 12. Now, first and foremost, the signs. If your last term is negative and your coefficient of x squared is positive 1, we know that that means that our signs are different. So a positive and a negative occupy the first and the second right. Our factors of 12 that when we multiply give us 12, but when we add give us a positive 4 are actually going to be 6 and 2. 6 times negative 2 gives us negative 12, whereas 6 minus 2 gives us 4. We have x plus 6 into x minus 2 all over x plus 6. So if we look at our function again, f of x, it is equal to x plus 6 into x minus 2 over x plus 6. Okay. Now to simplify further, after factorizing, okay, and then obviously putting then our x plus 6 in brackets to indicate that we've taken out a common factor of 1, we can now see that the x plus 6 and the x plus 6 cancel. So after simplifying through factorizing, we cancel and further simplify, and we are left with f of x is equal to x minus 2. Okay, that's what we are left with as our function. Okay. Now the reality is that we are only able to cancel x plus 6 and x plus 6, and we are left with x minus 2 in the numerator. Okay. Okay. Now, this function tells us that x cannot be 6. Okay. Because if x is equal, x cannot be negative 6. Why am I saying x cannot? X cannot be negative 6. That is our restriction. X cannot be negative 6. What happens if x is negative 6? It would mean that the function is undefined. Where is it undefined? It's undefined where x is equal to negative 6. If x is equal to negative 6, then the function is not defined. Okay, the function does not exist where x is equal to negative 6. It exists everywhere else, but it just does not exist where x is equal to negative 6. Okay, right? So something that we can say is that if x is equal to negative 6, we know that the denominator of the original function, the denominator of f of x originally, right, the denominator of f of x originally becomes 0, and therefore the function, therefore f of x is not defined if x is equal to negative 6. That is very clear, guys, because we know that a 0 denominator means that the function is not defined. Do you guys know what that actually means? What that actually means is the domain of the function doesn't include x is equal to negative 6. So in other words, we can say that x is an element of real numbers, but x cannot be negative 6. This function here is defined everywhere for x, except where x is equal to negative 6. X cannot be negative 6. Okay? Right? Right. So I hope you are following my trail of thought so far. Okay? But now here's the thing. If x cannot be negative 6, my question then is, where or what happens to the values of y, all right, as x gets closer and closer to negative 6? Let me repeat this again. My question is, what happens to y for the function when x gets closer to negative 6. We know that when x is equal to negative 6, the function is not defined. But our question is, what happens to y? What are the values of y, in other words, for the function, as x gets nearer and nearer to negative 6? Okay. What happens to y? What is the value of y? Or which value of y does the function get closer to as x approaches negative 6? Okay. We know that at negative 6, the function is not defined. Thank you so much for the You Awesome Science Genie. I really appreciate the 5 You Awesomes. Thank you so much for the gifts. What happens as x gets closer to negative 6? We know at negative 6 the function is not defined, but the question that we have is, what happens as x gets closer and closer to negative 6? What is the value of y approaching? Okay, so we know that this is the function that we get after simplifying. F of x is equal to x minus 2. What type of function of this is this? It's a straight line function. So if we were to sketch it, let's sketch it, guys. X is equal to x minus 2. This is a straight line that has a positive gradient. So what we're expecting here is a straight line that is increasing, that has a y-intercept of negative 2. Okay. So if we were to sketch this function, okay, let's just have a nice Cartesian plane there. Okay. So if we are to sketch the function, guys, the actual function of y is equal to x minus 2. If we let y be equal to 0, we get x minus 2, which gives you x is equal to 2. So the coordinates are 2 and 0. 2 and 0. So when y is equal to 0, x is equal to negative 2. X minus 2. Take the negative 2 over, we get 2, right? So x is equal to 2. When x is equal to 0, y is equal to negative 2. So that's 0 and negative 2. So the function will be here. 0 and negative 2 are located there, and x is equal to 2 is located there. Okay, so we can draw the straight line like that. But let us take careful note. We learned here that x cannot be negative 6. So we need to take note that when x is equal to negative 6, where does the function, as x gets closer and closer to negative 6, where does the function approach? For y, as x gets closer and closer to negative 6, what value of y does it approach? We know that x cannot be negative 6, all right? But if we come here to this function and substitute the negative 6, all right, we get negative 8, but we know that the function cannot exist here at negative 8. So what we do is that for the straight line that we draw a straight line, but then this straight line has a hole. Okay, straight line has a hole. Forgive me for the straight line that is a bit it's It's a bit wavy. It's a bit wavy. It's a bit wavy. All right. But this diagram, this straight line, is a representation of f of x is equal to x squared plus 4x minus 12 over x plus 6. Remember, x cannot be negative 6 because when x is equal to negative 6, the function is not defined. It's undefined. So that is why for our straight line, okay, I'm sorry guys, that straight line that is drawn there, I think does not make the point valid. Let's just say the 2, the negative 2. Okay, let me just wow, I'm having a hard time locating a ruler, that's for sure. Wow. Okay, I think I'm gonna have to improvise. I'm going to have to improvise. What kind of teacher doesn't have a ruler out there? What the hell? Yeah, I wanted to give them a graphical representation. My soul. Yeah. So guys, here it is. This is what it means. Okay. So f of x is equal to x plus 6 into x minus 2 over x plus 6. All right. Remember, this f of x, the function itself, okay, is not defined where x is equal to negative 6, because if you substitute negative 6 in the denominator, we know negative 6 plus 6 will give you 0. All right, so x cannot be negative 6. Simplifying this function, all right, algebraically, gives us f of x is equal to x minus 2. We know that this is a straight line function. This straight line function, okay, drawn can be represented as the straight line, but we know that where x is equal to negative 6, the function is not defined, which is why we put a open dot where x is negative 6, okay, because x cannot be negative 6. All right, but here's the thing. If you remember, we said that if x is equal to negative 6, okay, the denominator f of x originally becomes 0, as we had explained. If x is equal to negative 6, the denominator becomes 0, okay? So we say that x is equal to negative 6 is where the function is not defined. It's not defined where x is equal to negative 6. Then if we speak about the domain, remember the domain, guys, is the possible x values where the function exists. The domain of the function doesn't include x is equal to negative 6. Why? Because the function originally has a denominator expression, which is x plus 6, where if x is equal to negative 6, we have a problem. The function is not defined. Where is it not defined? Exactly where x is equal to negative 6. Hence, we have a open dot where x is equal to negative 6. But here's the thing. As x approaches negative 6 from the right, the y value gets closer and closer to which value of y? Negative 8. And as x gets closer and closer to negative 6 from the left, the y value approaches which value of y? Negative 8. So to explain this, or to represent this phenomena in words, all right, we introduce a notation, all right, to explain this in words. Because as x approaches negative 6 from the right, y gets closer to negative 8. It gets closer to negative 8. As x approaches negative 6 from the left, once again, remember, as x increases, y is also increasing for the straight line. So it gets closer and closer to negative 8, but it does not actually arrive at negative 8. It approaches negative 8 as x approaches negative 6 from the left, and as x approaches negative 6 from the right, it gets closer to negative 8 for y again. So the notation we use to explain this is what we call the limit concept. The limit concept explains this sort of phenomena where for your domain, a certain x value is approached, and as a result, as x is approached from the right and from the left, there is a specific y value that is what we call the limit. All right, it's like a limit value, the value of y that also gets approached from both sides. Because from both sides, from the right and from the left, as x is approached, it gets closer and closer to which y value? Y is equal to negative 8. So to write this then in a plausible, acceptable notation, to appropriately describe this so that it is mathematically represented, this is what we say. We say the limit, so we use short form notation, the limit as in like LMIT, but then mathematically we write in short lim, all right? The limit. Now remember, what were we talking about? We were talking about the limit of f of x. What is f of x? So it's the limit of x plus 6 into x minus 2 over x plus 6. The limit of what? The limit of x plus 6 into x minus 6 over x plus 6. As x approaches negative 6, I repeat again, the limit of x plus 6 into x minus 6 over x plus 6 as x approaches negative 6. All right. Now, if we're looking at this diagram, what is the limit of this function as x approaches negative 6. So from the left, okay, as we approach negative 6, and from the right, as we approach negative 6, there seems to be a common value that we are approaching on either side. And that output y value that we approach is equal to negative 8. So this is how we represent this in limit notation form. This is the notation we use to appropriately describe what is happening as we approach negative 6 from the right and the negative 6 from the left. There is this y value, which is the limit value that we appropriately approach. Okay, so I repeat again, the limit of x plus 6 into x minus 2 over x plus 6 as x approaches, or as x tends towards negative 6, is equal to negative 8. Right? So this is not to say that x is equal to negative 6. Rather, this means as x approaches negative 6, it simultaneously for the y values approaches negative 8. Not that it reaches negative 8, but it approaches negative 8. It gets closer and closer to negative 8 as x gets closer and closer to negative 6 for this particular function. So here we always station the function concerned. Here we talk about the x value that is being approached, and here we talk about the y value that is simultaneously being approached as a certain x value is being approached from left and from the right. That is the limit concept. Okay, so when you read that thing, how do you read it? You read it exactly as I've said it. You say the limit, you read it like that, the limit of x plus 6 into x minus 2 the limit of x plus 6 into x minus 2 over x plus 6 as x tends to negative 6. Okay, and when you say x is tending to negative 6, we are speaking from both your left and right. Okay, from left and right, guys. Is equal to negative 8. That's how you read what I just wrote down. This is how you read this. This is read as that. The limit of x plus 6 into x minus 2 over x plus 6 as x tends towards negative 6 is equal to negative 8. The limit of x plus 6 into x minus 2 over x plus 6 as x tends towards negative 6 is equal to negative 8. That's how you read a limit. Okay, that's how you read that notation. So I hope we are all able to read that notation at all times. Okay, I hope that's clear. Now guys, there are times, or let me just say, for this particular function, right, that we drew here, we can see that we are up as we approach, or as we tend towards negative 6 from the right and as we tend towards negative 6 from the left, we are actually approaching the same y value, which is negative 8. So it is appropriate to then say the limit is -8 because from the left and from the right we are approaching the same value. When we are approaching the same value, then it is appropriate to write that same value that we are approaching as the limit. Okay. I want you to look at this situation. This is like another scenario that is very possible. I mean, with limits, guys, anything is possible. Let's say we had f of x, and the sketch of f of x was such that it's what you see being drawn here in the diagram. Okay. So in other words, exactly what you see in the diagram. Okay. A situation where a function tends, okay, towards different limits. Okay, and maybe you're like looking at this and you're like, what does that even mean? Tending towards different limits. From the previous example, we were tending towards the same limit, which was -8. But in this particular scenario, we are tending towards different limits. Okay. How so? Okay. So there's a line here. Okay. We include the y value 3. All right. And then this is as x approaches what? Okay. As we are coming from the right, x approaches, we are approaching 0. Remember, the x value that represents the y-axis is 0. So as x tends towards 0, okay, so this is like the limit of a particular function. Let's just say it's f of x, generally speaking. The limit of f of x, which is f of x, is represented by this sketch, the line here, okay, which stops right there, and the line that picks up from there, it stops there. So the limit of f of x as x approaches 0. So from the right, as we approach 0, we get +3 from the right. And as we approach 0 from the left, we get -3. So the y values are different. As we approach 0 from the right, we are getting 3. As we approach 0 from the left, we get -3. So what does that then mean? It means we have different limits. Unlike the previous example, where when we are approaching the function from the left and from the right, approaching a certain value of x from the left and the right, we got the same value. So when we have situations where we are approaching, okay, the function from the left and from the right, and we get different limits, then we basically then conclude that if for one situation, okay, we approach the limit of f of x as x approaches 0. Now guys, listen to me. If we put a negative sign at the top, this simply means that we are specifying that we are approaching from the left. That's what the negative sign means. If we are approaching from the left, guys, okay, from the left, remember this is the function, and then it picks up and goes on like that. So the function is increasing, there's an inclusion there of the y value, then it picks up and increases again with the inclusion of +3 there. So as the function approaches 0 from the left, the negative means from the left, then we know that our limit is -3. But as the limit of f of x, as x approaches 0 from the right, when we approach 0 from the right, the limit is equal to 3. So do you see, guys, that our limit values from the left and from the right are different. If that is the case, since the f of x does not approach the same value, then we can conclude that the limit as x tends towards 0 does not exist. So we can therefore conclude that the limit of f of x as x tends towards 0. Now you see we put 0 now, not having a plus or a minus sign, because this is us making the conclusion. What is the limit of f of x as x tends towards 0? We've looked at from the left and what the limit value is. It's -3. We've looked as when it tends towards 0 from the right, and we found that there's a different limit value. Therefore, we can conclude that the limit of f of x completely now, as x approaches 0, we simply say doesn't exist. Okay. Or in other words, we can say it's undefined. Why are we saying it's undefined? Because guys, if we are dealing with a certain function, and as we approach a certain value of that function from both sides, and we find that from the left there's a certain limit and from the right there's a different limit, then it therefore means that the limit of that function as it approaches that a specific x value simply does not exist. It cannot be defined. And that's basically what we say when the limit values are approaching from left, giving us one limit, and then approaching from right, giving us a different limit. Then we basically conclude that the limit of that function as it approaches that specific value basically does not exist. The limit does not exist, because we can't have two different values, for our limit as the function is approaching a certain value from both left and right. The values must be the same in order for the limit to actually be defined and for it to be a specific value. Okay. Can I move on? The person who I'm speaking to knows who I'm speaking to. So can I move on? Do we at least have some sort of comprehension, even if it's slight, about the whole concept of the limit? Because we need to have a conceptual understanding of the limit. If we have that initial understanding of the concept of a limit, then we can dare say that everything else that is to come is going to be possibly understandable. But if we don't have an understanding of the concept of a limit, it becomes a bit problematic for calculus, the differential calculus, that is. Okay. I don't know how I'm going to get confirmation as well as to whether we understand or we don't. Okay. Yeah. Okay, thumbs up. Rona. Okay, let's move on. So, what can we conclude from what we've learned? As long as from the left and the right, as we approach a specific x values, the limit is the same, then that limit exists, and we can actually define what it is, and we can specify what that value is. But if we are approaching from the left and the right and we are getting different limits, then we cannot actually say that the limit exists. Okay. All right. So yeah, Fish Trout, you're gonna have to catch me live again tomorrow morning with that Euclidean geometry. Yeah. It's just that yeah, I had to end it. It became a bit busier and rowdy in my environment, so I couldn't really focus or concentrate or really give you guys my all there in that live, so I had to end it. Otherwise, I'm sorry about that, but yeah, catch me again tomorrow morning, kind of around about the same time. Okay, so yeah. I think we are getting, or we have gotten somewhere with that. So let us look at a few problems, if you want to call it that. Let's see if we really comprehend the limit concept. So now, if I said what is the limit of 7 as x approaches 1? Give me the value of the limit of 7 as x approaches 1. Let's see, the comment section should be ablaze. The limit of 7 as x approaches 1. And so hopefully we will be able to get to some conclusions about this, so that yeah, we can determine or evaluate the following limit or simplify. The limit of 7 as x approaches 1. Okay. Kuhle konke is saying 7 with a very hard crying face, with tears in her eyes. Tears in her eyes that she can never return back. So yes, guys, the limit of 7. Okay, the way I want to look at it is that this is a constant. It represents a function, right? You know that if we have a function and it is equal to 7, right? What that means, this is y is equal to 7. Y is equal to 7 is simply, on the Cartesian plane, a horizontal line that cuts the y-axis at 7. Because a horizontal line that cuts the y-axis at 7, any horizontal line has a gradient of 0 and the y values are the same everywhere. Y is constant everywhere on that horizontal line. So then the question that is being asked here is, what is the limit of this function as x approaches 1? Now the reality is that the value of 1 for x is here. The question is, what happens as we approach 1 from the left? What is the y value? What happens to the x value as we approach? What happens as we approach 1 from the right? What is the limit? So I'm sure you guys can see what the limit is. Whether we are approaching 1 from the left, or we are approaching 1 from the right, the limit, meaning the y value, is going to be the value of the function itself. Because for any constant which is representing a horizontal straight line, we are approaching the same value for that particular constant. So therefore, as we approach the function from the right, the y value is 7. As we approach the x value of 1 from the left, the y value is still 7. Therefore, it means that the limit of 7 as x approaches 1, remember this 1 represents for both left and right, we have the same value that we are attaining, and that same value is 7. Yeah. So that's what gives rise to the idea that the limit of a constant is equal to that constant. Okay, that's where the concept of a limit of a constant is always going to give us that constant. Okay, whatever it is approaching, whatever value that x is approaching or tending towards, the limit of a constant is equal to that constant. I hope it makes graphical sense more than it just makes, knowledge sense, because it's something that we are concluding, but it must make graphical sense. You understand it graphically that, oh, that's why we say the limit of a constant is equal to a constant. Okay. It is practically sensible what they are saying here. Okay. 2. Let's move on. The limit of x minus 1 as x tends towards 2 or approaches 2. What is the limit of x minus 1 as x approaches 2? Come on, guys. Comment section should be a place. I need you guys to be really quick and efficient. What is the limit of x minus 1 as x approaches or tends towards 2? Zigisa is saying it's x minus 1. No. Zigisa. No. Zigisa. Remember, x minus 1 is not a constant. Okay. 7 was a constant. That's why we said the limit of 7 as x approaches 1 is 7. X minus 1 is not a constant. Okay. Yeah, be very careful, Zigisa. Okay. Yeah. What is the limit of x minus 1 as x tends towards 2? Kuhle konke with the characteristic question mark. Okay, so first it was tears, and now it's a question mark. Hayi kuhle konke indeed. All right, yeah, it will be konke will be kuhle when kuhle is very sure about what she says. That day will bring so much joy. I struggle with calculus. Well, you're not alone. The person who invited me to do this session, you are not alone. Don't worry, you are in good company. Okay, you are in good company. We are all struggling. We are all going to actually not struggle anymore. Kuhle konke, surprisingly enough, with your struggle, your answer is correct. The limit of x minus 1 as x approaches 2 is 1. Why is that the case? Graphically, we can make sense of this if you want to really think about it practically. Here is our Cartesian plane. We know that a function like this, if we find the y-intercepts, okay, positive gradient straight line, of course, this is a representation of a positive gradient straight line. And I'm going to explain this so that you can then understand why it is that we are going to do what I'm going to do after explaining the graphical representation. It's helpful to see the graphical representation. At this stage, we should be able to visually see the graphical representation. We've done functions in grade 10. We did functions in grade 11. We are now in grade 12. We did functions in term 1. So we are at a place where we are looking at this x minus 1. The graphical representation should come very soon. You let y be equal to 0, you get x is equal to positive 1. That x is equal to positive 1, there it is. You let x be equal to 0, you get y is equal to negative 1. That negative 1 is definitely here. Okay. We don't have any places where the function is not defined because we don't have a denominator where we had initially simplified. So now we are looking at where x approaches 2. Okay. So we draw the sketch of the function. Of course, we know that somewhere there is the x is equal to 2. Our interest is from the left and from the right. As we approach this value of 2, what y value is actually being approached at the same time? What is the limit? So in order to get the limit, wouldn't we then take 2 and substitute it in the place of x so that we get the corresponding y value, which will present us with the value of the limit? Okay, would that be then appropriate? Definitely, guys. If we take 2 and substitute it into the function, we should get the corresponding y value. It is actually a y value that exists. When we approach the function as x approaches 2 from the left, the limit is 1. As x approaches 2 from the right, the limit is 1. So therefore, our limit of x minus 1, as x approaches 2, we saw that both from the left and from the right, we are approaching 1. So it definitely is equal to 1. So kuhle konke, I want you from today onwards to never doubt the authenticity and the truth of the answer you gave me. You should now know for sure, and you should have the evidence that substantiates why you actually write down your answer. So conceptually, what your answer was sound. Now you need to be confidently sure and not allow yourself to sort of like be swayed by the winds and the waves and the tides and the emotions of the time. Then give me question marks and the what else did you give me earlier on? Tears. All right. Yeah. Unless you want to give me tears of joy, I'll be very happy about that. Okay. Let's move on, guys. Let's move on. The limit of 10 as x approaches 1. Now I want to see if you guys have internalized what I've just explained to you. The limit of 10 as x approaches 1. The comment section should be getting better now. What's the limit of 10 as x approaches 1? No tears. No heartaches. No nothing. I don't want to see any of that. What's the limit of 10 as x approaches 1? Hey, boy, now. Okay, kuhle konke, thank you so much. 10. Zigisa MDCD na 10. Okay, thank you. All right, definitely. Remember, f of x being equal to 10, that's a horizontal line again. That is y is equal to 10. So of course, as you approach as x tends to 1 from left and right, it should actually be 10. The limit of a constant is that constant. Very good. Good job. Okay. We are growing. Growing higher and higher. Okay, we are growing, guys. We are growing. 4. Let's look at another. The limit of x plus 4 as x approaches 2. From simplicity to complex. We will get there, guys. Simplicity, we're starting simple, and we will definitely grow higher and higher. So, the limit of x plus 4 as x approaches 2, let's be very careful. The limit, yes, kuhle konke. Kuhle konke is playing the game very well. Okay, the limit of x plus 4 as x approaches 2. All right. Once again, we have nowhere where the function is undefined. We have a straight line. Obviously, it's in the form of x plus 4. So that is, gradient is positive. It's an increasing straight line. So we are looking at when as x approaches 2 from the left and the right. This is a simple substitution. It does not need anything. We know that as x approaches 2 from left and right, it basically reaches the limit, which is 6. Okay, good job to those that actually. Let's move on. Let's move, guys. Let's move. The limit of x squared minus 100 over x minus 10 as x approaches 10. the limit of x squared minus 100 over x minus 10 as x approaches 10. Okay. Before we get to the answer, there's a few preliminary steps that we need to actually take here. You know, steps that have to do with simplification before the limit is applied. We do not apply the limit just yet, because here we are running into a potential problem. Crash, is that a question mark? You are also getting into the habit of typing. My gosh. Crash is also playing the question mark game. Okay. All right. Yes. It is 20 Crash. Okay. Confidently, you should also be someone that goes ahead and writes the answer that is appropriate. So yes. Okay, so here, guys, there's a few steps that we perform because we see that substitution immediately in the denominator, 10 minus 10 is 0. That's where the function is not defined. The function is not defined at 10. Okay, so we know that's where the function is not defined. You know, so as x approaches 10, though, we are interested specifically as x approaches 10 from left and right, what is the limit of the function? Okay, so what we do is we first simplify the expression. So we write down the lim, and if we look at the numerator, this is a difference of two squares. So we can factorize this. We open two brackets. So you see, our skills, our algebraic skills are very much needed in calculus. And guys, there's no place where all of our algebraic skills, the culmination of everything that you've learned in algebra, comes together here in calculus. So difference of two squares, when you factorize this, okay, x squared minus 100, we know that's going to be a plus and minus because a negative constant means different signs. The square root of 100 is 10. So we put 10 and 10. The square root of x squared is x and x. All right. That is going to be written all over x minus 10. We also put this in brackets to indicate that we acknowledge that the highest common factor of 1 is taken out, and then we write x minus 10 in brackets. When we have brackets like this, the relationship between the brackets, multiply and just divide alone. Cancellation of common things, top and bottom, is allowed. So what do? X minus 10 and x minus 10 go. Okay, let's not forget as x approaches 10, we write the limit as x approaches 10 of x plus 10. So we are exactly where Presh basically said we could be. We then know that the limit of x plus 10 as x approaches 10, we can now go ahead and say 10 plus 10, which is 20. That is the limit. That is the limit. Okay. So that is the value, my leader. That is the value. That is the value. Okay. It's 10. It is 10. Right. Are we clear? Are we good? Yeah, we're good. Don't know if there's any question about that. So I'm hoping that you will also be able to confidently do these seamlessly. No issues, no problems. Whatsoever. Okay. Okay. Let's move. Let's do another one. Okay, I'm just gonna throw a lot now. the limit so that procedure from the previous problem is that we need to simplify the expression, cancel all common terms, simplify, factorize, cancel what's common top and bottom, and then of course we calculate the limit. It's kind of like the step-by-step procedure that we follow. So here's another one, the limit of x squared minus x over x as x approaches 0 or tends towards 0. The words that we use there, approaches, gets closer and closer, tends to, approaches. These are the words that we use. Aibo, Presh, what's up with the question marks? Wena kanjani? Ke tla sebedisa matla a ka kore sharper. Still getting there how my foot. You can take my foot. This one. The limit of x squared minus x over x as x tends towards 0 or approaches 0. Guys, I don't know, is the visual okay for you guys? Because my phone is doing funky stuff right now. There is that, sort of like delay circle going round and round and round and round. I might have to end the live and restart it because I don't know what's happening here. Just let me know if you can't see or if, I don't know, there's funky stuff happening. It's fine-ish. Yeah, it's making it difficult for me to be able to see. Just the insanity. Okay. Alright, so here we can see at the top factorization is possible. What type of factorization? Highest common factor. So what do? We take out the highest common factor x. That leaves us with x into x minus 1 over x. Then we keep the limit, we cancel, that leaves us with x minus 1. You see? Then we substitute the 0. Okay, what does substitution of 0 into the x mean? It leads us to -1. We could not substitute the 0 initially whilst we had not factorized, but after factorization, simplification and cancellation, 0 can be substituted. Now we know that as x approaches 0 in the function, the limit is -1. Okay, good job, Adazion. I can see you are happy as well because you did the right thing. Guys, I'm going to probably have to end this live and restart it because I don't know, this thing here is giving me, it's not showing properly now. It's going round and round, it's doing funky stuff my side. You guys can see, you're saying everything is fine. I'm just a bit weary that it's gonna keep on doing this, and then before I know it, it's just gonna kick me out or something like that. The limit of -1 as x approaches 2 is equal to, come on, let's see you guys, come on. Limit of -1 as x approaches 2, what's the answer? The limit of -1 as x approaches 2. Okay, you should all know this by now. Okay, you should all know this by now. The limit of x, the limit of -1 as x approaches 2. What kind of question is that? Where are you from? What in the world? Please, guys, don't tell this guy who's asking me where I'm from. You never know. People do funky stuff nowadays. He might as well do something funny and come and abduct me here. Yeah, that's why the answer is -1, because the 0 has been subbed. Okay, I go ahead and I say this whole entire thing is equal to -1 because of the subbing of the 0 in the place of x. So it has been subbed. Okay, this one is equal to -1 because we know that the limit of a constant is equal to that very constant. That you should know by now. The limit of x minus 5 as x tends towards 5. The limit of x minus 7 as x tends towards 5. Just take it in, guys. I know some of you are like, this guy, why is he giving us basic stuff? Take it. I need you to internalize the concept, okay? Ada Zion's collection, good job. So proud. You're making daddy proud. Thank you so much. So emotional. You're making me so emotional when you guys answer well. Okay, yes. 5 minus 7. Okay, straightforward this one. Okay, no factorization needed. The expression for our f of x function is already 2 terms simplified, so we just substitute 5. We know the answer. Okay, -2. Good job. Let's go. All right. The limit of x squared plus 3x minus 4 over x minus 1 as x approaches 1. Let's go. My people that can't factorize will be delayed. And people who can't factorize, who struggle with factorization, will delay their progress. But those who can factorize seamlessly, progress will not be delayed, my people. Yes, Presh. Yes, Z. We got them answers. Kuhle konke. Everything is well, isn't it? Everything is super well. Yes. Okay, guys. Good job. I'm sure if I was to ask you what you guys did, the process, you would tell me that you limmed, you factorized, you opened 2 brackets. You know that when the sign is negative, the signs are not going to be the same, positive and negative. Factors of 4, when you multiply give you 4, when you add give you 3. We know it's positive 4 and negative 1. The x and the x there. We kind of get guided that it should be x minus 1 because at the bottom we have x minus 1. That's kind of like giving clue vibes. We cancel the limit as x approaches 1 of x plus 4. The substitution happens right there. That 1 plus 4 gives us 5. Good job, Ada Zion. So we basically get the limit of x plus 4 as x approaches 1 is equal to 5. Okay. Let's go. We are moving. We are moving. The limit of h squared minus 9 over h plus 3 as h approaches negative 3. Guys, that's negative 3, okay? The limit of h squared minus 9 over h plus 3 as h approaches negative 3. Let's go. My God. Why are you guys pumping up all the answers, man? It's like you guys don't even give the poor people a chance. I think these guys are using AI. You must be using AI. Gauth Math or something. Gauth Math AI, or it must be some AI engine that you guys are using. Because you're writing answers when I literally about finish answering the question. I mean writing the question. How is that? Kuyaphuthuma. How? How's it? Kuyaphuthuma. You guys are too puthumaring if you ask me. It's puthumaring on another level. It's puthumaring on another level. What manner of puthumaring is this? Ada Zion got 12. We'll have to reconcile that value very soon and see. Ada Zion, we'll see. Okay, so negative 3, right? I said this is negative 3. Okay, so let's check this out. How do we do this? We would say the lim h approaches negative 3, h squared minus 9. This is the difference of two squares factorization. So we have dots factorization. So we open two brackets. We have h and h. Since it's a negative constant, we have positive 3 and negative 3, because the square root of h squared is h. The square root of 9 is 3. All over h plus 3. We know that these two cancel. We are left with h minus 3. Then of course what happens? Our substitution happens seamlessly, right? And then oh my soul, I think we will never hear the end of that rematch. My goodness. So it's negative 6, guys. Negative 6 indeed. So good job to those that got the answer. Those that didn't, just make sure that whatever misconception or missed thinking process that you may have omitted is re-established, okay? Guys, don't be scared. Oh, you see your mistake. I hope you do, because we don't want to be consistently making those kinds of mistakes, right? We want to make sure that we are making sure that we are making sure. Okay. Here's another. Mambo number 6. The limit of x squared plus 6x plus 5 over x plus 1 as x approaches a negative 1. Ole, 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 ole. Hey, I can't put two, oh my goodness. Yo, I corner pressure Z. Pressure Z. The Z and press. Z press. Z press. Z press. Yeah, I think that's a nice combo, eh? Z fresh. Z fresh. You know, the pH, right, can also be, yeah, look at that, Z fresh. Z fresh. Okay, the limit of x squared plus 6x plus 5 over x plus 1 as x tends towards -1. Okay, it seems like we are kind of like embracing it seems like a common answer there has been established by Zpresh. So hence I was saying, guys, that here your skill of factorization will actually count towards your favor, but if it's lacking, then it will basically be the one that will hinder progress. It will hinder progress. Okay. Ada Zion. Okay, we got 4 as well. I'm kind of sad that I can't even tap my claps, man. This is just driving me bananas. My phone just got onto this like that round and round thing is up, and I can't click on anything. Okay. Yeah, guys, I'll be giving you all sorts of claps and cheers, but I can't because my phone is frozen. But you guys are saying you can see everything and all of that stuff, so I'm just gonna leave it. So yes, guys, we factorize. This is like, we know that the factors are going to have the same signs as the sign of the middle term. So plus plus. Factors of 5, we have 5 and 1, because 5 times 1 is 5, but 5 plus 1 is 6. Boom, boom, cancel. Let's not forget the limit as x approaches -1. You don't ever want to forget that. So we are left with x plus 5. And then, of course, 1 plus 5, which is 6. Just kidding, guys. It's -1, obviously, plus 5, which gives us 4. Could see some of you getting a heart attack and being like, no, you are wrong. Yeah, well, hopefully that will erase question marks, right? Because people are obviously sure about what they're writing, and it's not like they don't know, right? Okay. Yeah. Okay, let's wrap up with the last 2 limit questions. At least you guys, I'm sure, are getting the point. Let's do lim of x approaches 0 for 3a plus 1 over 3a. What is the limit? Billy. Okay, others collection saying it's 1. Let's see. Let's just wait for other people to respond. What is the limit of 3a plus 1 over 3a as x approaches 0? What is the limit? Oh, thank you so much, Z. Oh my goodness, 20 awesomes. Sure. Whatever did a man do to deserve those? Thank you so much. You are so kind. You see now, I'm deprived. I can't even clap for you for crying out loud. As I said, this screen of mine, I don't know what it's doing. I am so tempted to kind of end this live and restart again because it actually ekes me out that I can't clap. I can't clap for anyone. Well, I guess I can with my hands, right? But that's like, I love the artificial TikTok clap. Okay. Amen. Thank you so much for the 20, you awesomes. I really appreciate them. Sure. Thanks. Oh, you are good nighting out. Okay, good night, dear. Thank you. You're amazing. Thank you so much. Z is such an angel, man. Thank you. Thank you. Thank you, Z. Supporting the live like that. Really appreciate you. Thank you. Thank you. Right, guys. The limit of 3a plus 1 over 3a. Okay, Precious saying 0 with a question mark. Undefined. Seems like you are changing things up every time. Changing up the answers, changing up the answers. Oh, sorry guys. I think it's me that sorry. I was wondering why you guys are taking such a long time. I wrote A and then I wrote X here. Sorry guys. My mistake. It's my fault. Forgive me. Please forgive me. So it's A, not X. It's just that all the other questions were X, 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 and now I just kind of fell into the casual writing of X. Sorry. So it's the limit of 3a plus 1 over 3a as a approaches 0. My bad. My mistake. Sorry. Okay, so re-looking at it again, guys, with the a, sorry, not with the x. So the limit of 3a plus 1 over 3a as a tends towards 0. Okay, so hopefully you guys can see that this is actually can't be 1. Okay, it's not 1, guys. It is actually. So even if you were to simplify this, right, so that it is actually 9a squared plus 1 over 3a. Okay. This, guys, is still in the denominator, is going to have the a there, which means it's undefined. So the limit is not defined. Okay. In other words, doesn't exist. Okay. All right. So I hope we're clear there. Okay, I hope we're clear there. Okay, thank you. Oh, finally it's back. Okay. Okay. Yeah, Maxwell is like, do more. Are we still fine, guys? Are we still okay? The limit as x approaches 2, x minus 3 over x squared minus 3x. Okay. Sorry, I'm sorry for that. Limit of x minus 3 over x squared minus 3x as x approaches 2. The limit of x minus 3 over x squared minus 3x as x tends to 2 or approaches 2. Yo, Crash, I corner. My girl. Type of when you are just my girl, that's for sure. It's indicative of a daughter of mine. Ada Zion's collection half as well. It was very quick, guys. Very quick. Moving quite swiftly, hey? Like people are moving quite swiftly, you know? Like people are moving quite swiftly. Like there's no people are definitely not messing around, are they? People are moving quite swiftly. It's phenomenal to watch. Like people are just moving swiftly. Okay. Alright. I'm happy, guys, that we are moving quite swiftly. Yeah. As long as we can see that in the denominator there is a substitution that won't lead to 0, then we can do the clear substitution without factorizing. But I guess it's so common for people to play the factorization game, right? Then when they do, the limit as x tends towards 0, 1 over x. Then what do? We just go ahead and substitute. So it is 1 over 2. 100% half. So good job, guys. Good job. So proud. Okay. Yeah. The cancellation in the numerator obviously leaves 1 in the numerator. And I think that's something sometimes people tend to forget, or they tend to ignore, that there's a 1 that gets left behind if you cancel everything in that, in the numerator. Okay. Let's never forget that. Otherwise, we will be crying. Limit of x squared minus 9 over x plus 3 as x tends towards negative 3. Boom, 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 boom. Is the mathing, guys? Yo, press. As she decimates the field, leaving prisoners, leaving no stone unturned. That's like the victorious ones. The victorious ones. X squared minus 9 in the numerator, x plus 3 in the denominator. So what do we do there? Yeah, difference of 2 squares. Yeah, so we can factorize the top because the difference of 2 squares. Then we leave x plus 3 in the denominator, right? Don't forget the lim as x approaches negative 3 indeed. Then goodbye. Yes, good job, Ada. Good job, Ada. So minus 3. Remember, when the limit is, we are finally ready to substitute, we substitute, we get negative 6. So good job. Okay. The y value. Okay. Okay, one last one, guys. I think you guys get the point now. The limit of negative 3 as x approaches 5. Yeah. Yeah. Good job, Presh. Ada Zion, be very careful. We've been saying now for the past couple of problems that the limit of a constant number is equal to the actual constant itself. Okay, because if you take 5, you try and substitute 5 into negative 3, you can't. So that means that, because remember, this is a constant, so that means the limit of a constant is equal to a constant. There's actually a rule that says so. The limit of a constant as x tends towards any real number is equal to a constant. Okay, may you never forget it, dear. May you never forget it. Very crucial. Okay, So guys, now I want us to explore the concept of average gradient, because the limit concept I feel like I've exhausted. You guys see, you guys saw, you beheld. So hopefully that adds a bit of value to your knowledge. Okay, now we can speak about something called the average gradient, which will then lead us to the gradient at a point. All right. In grade 11, you guys did the average gradient, remember? Grade 11, when you did your parabola function, you could calculate gradient for a straight line, no problem, but then at a given point, all right, for a parabola, you guys looked at the concept of average gradient between any 2 points. That was grade 11. You looked at the gradient between any points on a curve, okay, and you would draw a straight line that passes through both those points, and then you'd use both those points to basically calculate the gradient, okay. So now we are going to look at the concept of average gradient. To look at it, we are going to sort of like explore the following. So follow along with me. This is the y-axis. This is the x-axis. Say we had a curve, or we have one. It has point P, right? Point P, right? And we will say that there's a specific value of x, which we will generally call a. The corresponding value of y will be called f of a, of course. If the x coordinate of P is a, then the y value is f of a. Right. Now, obviously, that's something you should know quite well. Let's say this is the function f of x. Okay. And let's say there is a particular point that is h distant away from a. Okay. Point Q, whose the x coordinate of a of P, sorry, the x coordinate of P is h distant away from the x coordinate of Q. Okay, so like I said, the x coordinate for for P is represented by a. The x coordinate for Q is h distant away from the x coordinate of Q. So the a plus h is just to indicate that we've added to a h to get basically the specific x coordinate that Q has. So this is the x coordinate of Q, it's a plus h. Then of course that would mean the corresponding y value will be equal to f of a plus h. Am I making sense to you guys so far? So So I'm talking about a curve here. We call it f of x. It has a point P, and then it has a point Q. All right. Let us then say that there is a secant line, right, between 2 points on this curve. All right. So as I said, Q is a point on the function. P is a point on the function. The x-coordinate of P is A. The corresponding y value of the point P is f of A. H distant away from A is A plus H, which represents the x-coordinate, because remember, on this same vertical line we have the x-coordinate of Q, and then the y-coordinate of Q is f of A plus H. That represents the y-coordinate of Q. So if we were to write down the coordinates, we'd have A plus H and f of A plus H, which are the x and the y coordinate of Q. So this is what we call a secant, right? Remember in your circle geometry, you had a secant, which was a line that basically extended beyond the boundaries of the circumference. So here we call this a secant line, okay? The secant line cuts through P and Q, right? So if we consider the point P and the point Q, okay, and their respective x and y coordinate, as you've understood them to be A and f of A, the x coordinate of Q, which is A plus H, and the corresponding y value, which is f of A plus H, okay? What we can do here is we can calculate the average gradient between P and Q. Since we cannot exactly find the gradient of the curve, we can calculate the average gradient using these 2 points, as we did in grade 11. So when we calculate the average gradient, our formula, my beautiful people, is going to be the average gradient is yq, the y coordinate of Q minus the y coordinate of P, over the x coordinate of Q minus the x coordinate of P. So in other words stated, we could say, what is the y coordinate of Q? Remember, the y coordinate of Q is f of A plus H. So you can say f of A plus H minus the y coordinate of P. Y coordinate of P is f of A over what? Over the x coordinate of what? Of Q. X coordinate of Q is A plus H minus the x coordinate of P. The x coordinate of P is A. Simplified, this is f of A plus H minus f of A all over. If we look at like terms here, A plus H minus A, that is going to give us H. This should be a very familiar outcome, okay? Now, I want you guys to now think together with me. want you guys to now think together with me. Think together with me. Okay? Think together with me. Think together with me, my grade 12s. Think together with me. Right? If I was to take this line and begin to move Q, what happens as I move Q? I can move Q until it is exactly, or it gets closer to P, right? There is the line, okay? But if I move this Q along the curve, thus affecting my secant, I can get my secant closer and closer to who? To P. I can get my Q closer and closer to what? To P. So you can see now, as I get my line closer and closer to P, you are going to see the line go like this. You see the very same line going like this. You see the very same line going like that. Okay. What happens as Q gets closer and closer to P? If you imagine that Q moves along the curve, getting closer and closer to P, what happens to the second line? The secant line approaches the tangent line as its limiting position. So as you basically move the secant from the point Q and get closer and closer to P, what happens is that the secant line will basically be approaches the tangent line as its limiting position. Okay. So now, guys, what conclusions are we bound to make? The thing is, the average gradient, guys, of the secant, the average gradient, which is this, what does it do? It approaches the average gradient of the secant approaches the gradient, and this is the most powerful thing here, it approaches the gradient of the tangent. It's almost as if the secant then, as it approaches P, approaches tangency, okay, to curved P, at P. That's what I mean. It approaches the gradient of the tangent to curve at P. That's what happens as P moves. That's what you are seeing here, guys. These lines are an indication of the secant line approaching P and getting closer and closer to tangency at P. Yeah. Okay. So as Q moves along the curve, getting closer and closer to P, what are we saying? The secant line approaches the tangent line as its limiting position. What does that then mean? This means the average gradient of the secant approaches the gradient of the tangent to the curve at P. And I'm repeating this thing over and over again because I need you to understand that. Okay? I need you to understand that. Where is the gradient of FQ? What do you mean, where is the gradient of FQ, my guy? What do you mean, where is the gradient of FQ? What is that question? What do you mean by that question? What kind of question are you asking? Where is the gradient of FQ? What do you mean by the T? What is that question? I don't understand that question. Where is the gradient of FQ? Who talked about the gradient of FQ? And what is that? What is FQ? What are you talking about? Yo. You see now, those kinds of questions, me, that's where I'm like, nah. Okay. All right. So hopefully, customer number 1 is hearing me. Okay. So as point Q approaches P, as point Q approaches P, what happens to my H? Because remember, A plus H was H away distant from A. But what happens as point Q approaches P? The H obviously is going to get closer and closer and closer to who? To 0. Okay. H, this, say, let's say this distance was, let's say this H was plus 3. To be here is plus 3. As Q moves, this H value will get reduced from 3 to then maybe 2, 1, and as it nearly coincides with P, the Q nearly coincides with P, or it becomes 1 with P, it means that this H value is approaching 0. If this Q would be exactly at P, then it means H is 0. But as it approaches P, as Q approaches P, as it gets closer and closer to P, it means H is tending towards 0. All right? It's tending towards 0. This is an important thing to note. Okay? So if as point Q approaches P, this H gets closer to 0. If point Q lies exactly on point P, then we would say H is equal to 0 because there's no longer an addition of a value of H which is not 0. When Q is exactly at P, it means we no longer have a distance apart, that is addition of an actual H which is a real number that is not 0. When Q is on P, it means H is equal to 0. This H, because we are adding 0 to who? To A, because we are there. We are exactly there. What's A plus 0? We are at A if A is added to 0. It means H is 0. But of course, as Q gets closer and closer to P, what is it approaching? It is approaching 0 because the H value is being reduced. All right. And what about the formula of the average gradient? Remember that this P and Q, as this A and this A plus H was away because the P and the Q were apart like this and the line, the secant was there. As Q approaches P, the formula for average gradient is what? Is undefined. Okay? If point Q lies on P and if Q is equal to P, Q is on P, then it means H is 0. And if H is 0, what does that mean? It means the average gradient is undefined. Why do we say the average gradient is undefined? Look, guys, remember this was the formula for average gradient. If H is equal to 0, what does that mean? In the denominator, that means that the average gradient is what? Undefined. So we don't want average gradient to be undefined. Rather, what do we want? Because we don't want H to be 0 and for the average gradient to be undefined, we use our knowledge of limits. We use our knowledge of limits. And what do? We let h tend toward 0. By doing that, we are able to determine the gradient of the tangent to the curve. By doing that, we're able to determine the what? The gradient of the tangent to the curve. At what? At point P. So what then is the gradient at point P? The gradient at point P is simply this. It is the limit as h approaches 0 of the average gradient. So that's what helps us. The gradient at a specific point will be the limit of f of a plus h minus f of a over h, which is the average gradient, when h approaches 0. That will help us then with the gradient of the tangent. You see? So this is very important. Okay. Fresh, my dear, speak to me. You know most primarily who I am, who is my customer here. You talk to me, speak to me. Customer. I need you here, nay, yea or nay. Yeah, P and Q, very important this thing. P and Q are part average gradient for the secant line. When Q moves towards P, H tends towards 0. At P, it is equal to 0. H is equal to 0, that is. But as Q moves towards P, it tends towards 0. So therefore we say, what do we say? We say that the gradient at the point P is defined by the limit of the average gradient as h approaches or tends towards 0. That's how we calculate the gradient at a point. Okay. The average gradient as h approaches or tends towards 0. We can use that formula. And that's what then leads us to calculating the gradient at a point, which is the precursor, or is what lays then the foundation to what we then get later on, first principles, and then the laws of differentiation. But before all of that, the limit concept needs to be understood. Then from the limit concept, we can be able to first understand how we get average gradient. We did average gradient in grade 11. The formula for average gradient was quite simple because we would always use 2 points to calculate the average gradient for a particular curve. But to specifically find the gradient at a specific point on a curve, we can incorporate the concept of average gradient. But first understand that these 2 points horizontally are of an h distant away from each other, the x values that is, from left to right. It's h distant away from A. But as we move P along the curve towards P, the secant becomes or is limited in its position by the tangent. We then say that this h, as it moves closer and closer to P, tends towards, the h tends towards 0. At the point, it's equal to 0. And we know that is where the function is undefined. So then we use or incorporate the definition of a limit, and we say as the limit of h approaches, not is equal to 0, but as the limit of h approaches 0 for the average gradient of a line, then by so doing we can calculate the gradient at which point? At point P, because the gradient at point P is the limit of the function as h approaches or tends towards 0. So now we can look at calculations gradient at point. If we are given, let's say g of x is equal to 3x squared, and they say determine the gradient of the curve at the point x is equal to -1. Okay. Then frankly, we can go ahead and what? Determine the gradient of the curve at point x is equal to -1. Why? Because we have a specific working formula which says what? Which says as the limit of h approaches 0 for g of a plus h minus g of a all over h, the gradient at that point is equal to what we see in this formula. Okay. Then what's always beautiful, guys, is that we can choose to basically not waste our time too much. Okay. You know, on the side we can get g of a plus h and g of a if we want, or we can substitute and simplify in the actual formula. It really depends what you as an individual wants. Okay. Now, since we know g of x is equal to 3x squared, remember here we want g of a plus h. But we remember from when we were looking at the formula that the a is a representation of x, and we are told specifically here that x is equal to -1. So what we do is we check g of a, which is equal to g of -1. In the place of x, we substitute 3 into -1 squared. We get 3 times 1, which is 3. That is our g of a. So we know who we are going to substitute in the place of g of a. g of a plus h, we are going to say g of a plus h is equal to g of negative 1 plus h. So in the place of x, we are going to substitute g of negative 1 plus h, which is equal to 3 into negative 1 plus h, the whole thing squared. Now it helps to know the quick short rules, guys, because we square the first term, we square the last term. Negative 1 is 1. H squared is positive h squared. To get the middle term, we multiply negative 1 times h. We get negative h. We double it. That gives us negative 2h. You distribute the 3. 3 times 1 is 3. Minus 6h plus 3h squared. That is g of a plus h. Then I'm going to take this and that, having gotten and simplified it on the side, come to the formula and then substitute g of a plus h. There it is, g of a plus h. So I just write that 3 minus 6h plus h squared minus g of a is 3 all over h. I know that is going to be my gradient of the point. Okay. Then we add like terms. 3 minus 3 is 0. I'm left with negative 6h plus h squared over h. The limit of, as h approaches 0, of negative 6x plus h squared. Take out, deliberately take out the negative, deliberately take out the positive h and leave everything else as it is. The h and the h cancel, still keeping these around. Then of course I'm left with the limit of negative 6 plus h as h approaches 0. Now we can substitute in the place of h 0 and get negative 6 plus 0, which is negative 6. So the gradient, determine the gradient of the curve at point is equal, x is equal to negative 1. The gradient is equal to negative 6 at point x is equal to negative 1. And that's incorporating the concept that we've just learned, guys. Okay. Are we clear? Are we clear? Are we clear? Are we clear? Are we clear, guys? So yeah, we were calculating here, guys, the gradient at a point. Okay, we were given g of x is equal to 3x squared. We were asked to determine the gradient of the curve at the point x is equal to -1. So we know the formula we use to calculate the gradient at a point is equal to the limit of g of a plus h, because we are dealing with g of x. If it was f of x, we would have said f of a plus h minus f of a. If it was h of x, we would have said h of a plus h minus h of a. Okay, so we limit of g of a plus h minus g of a over h as h approaches 0. So we sought first to take g of x so that we can get these functional notations and their expressions. So g of a was substituted. We know that a stands for x, so we said g of -1 in the place of x. And then we got 3 times -1, applied BODMAS because brackets exponents. We apply the exponent to the -1, then we multiply the 3 with the 1 later to get 3. That's g of a. So that's why we substituted -3 there. Next, we calculated g of a plus h, which is a means -1, of course, the x value. Then here we substitute the -1 plus h into this function. We got 3 into -1 plus h, the whole thing squared. Once again, BODMAS says we start with brackets followed by exponents. We apply the exponent to the two terms, square the first term, square the last, and then to get the middle term, we get the product of the two, -1 and h, and then we double it. Okay, then we take the 3 distributed inside the 3 terms. We got 3 minus 6h plus 3h squared. That's g of a plus h, which we substitute here. So we substitute g of a plus h minus g of a. The reason why I did it on the side is so as to avoid overcrowded values. I don't want things here to be overcrowded and for me to potentially make mistakes because there's so many terms and so many things substituted for the numerators. You know, there's simplification, addition of like terms, which I can at least get each individual expression simplified as it is. Just make sure that I do write it down first so that we know that, okay, g of a, there it is, it's 3, there it is. G of a plus h is 3 minus 6h plus 3h squared, there it is. We add the like terms, take out a common factor, cancel, and then we simplify. We only apply 0 when we have a expression that has no denominator, that is the variable h, and then we can actually check what the limit is. It's -6, but if we remember, this -6 is a representation of the gradient at the point x is equal to -1 in the function 3x squared. Okay, are we okay? Are we okay? So please guys, we only take the limit and substitute when we have removed the h by factorization and cancellation in the denominator. We only take the limit, get the actual value and substitute in the place of h when we have removed the h. Please guys, don't ever not remove the h first. We need to make sure we remove the h. Okay, since you've seen how I've done it, let me give you yours. Let me give you yours to do. given f of x is equal to 2x squared minus 5. Determine the gradient of the tangent to the curve at point x is equal to 2. Okay, you guys try this one out. Give you a chance. Hopefully you have a pen and paper out. I'm sorry guys, it's 28 minutes past 12. My goodness. What time are we cutting it off? I want my customer to tell me, when do I cut off the live? When should I end it? I will end it when you tell me to. I listen to you, so let me know in the comment section when you'd like me to stop. I'll stop when you want me to stop. If you want me to end at 3, I'll end at 3 a.m. I'll push until you are sick and tired of being sick and tired. Let me know. Thank you for the likes, guys. Really appreciate it. Happy birthday, Beyonce. Beyonce. Happy birthday, Beyonce. Happy birthday, Beyonce. We've got a happy birthday boy there. Wish for me happy birthday. Nick, happy birthday. Have a good one. Have a good one. Hey, Pressure, I'm waiting for you to answer again. Done. 1:30. White Rose is saying 1:30. Is that the mind we are all in? Nick, happy birthday, bro. Yeah. So these particular questions are for determining the gradient of the tangent to the curve at a specific point. All right. But remember, that does not mean they may not ask you to still calculate the average gradient. Okay? You already know how to calculate average gradient. So even when you are asked to calculate the average gradient, you have the formula of calculating the average gradient. So they could still ask you to calculate average gradient. You just need to always be in the know-how how to calculate average gradient. Here, we are being asked to calculate the gradient of the tangent to a point. So at a specific point. So that's why we use the limit. Because remember, we had spoken about Q approaching P. And when Q approaches P, what gets reduced? H. H now tends or approaches 0. So that's why we use the limit, because the limiting position of a secant as it approaches P is the tangent, the limiting. Yeah, I love the perception that comes sometimes. Okay, let me keep quiet. Doing the process. Let's go, let's go. Arieni, Arieni, Arieni. Hopefully it's coming together. You guys are answering the question. Yeah, you see. So it's nice that we get those basics in those basics. Nice basics. Okay, so hopefully we should be at least close to being done by now. If not done already, you can just let me know in the comment section what did you get for your gradient of the tangent. I'm sure the whole tangent thing now is fine. What did you guys get as the final answer at the end? 8. Yeah, I think I should. And remember, guys, this is before derivation. We are just building up towards derivation. This is before derivation. This is like the foundational stage before derivation. This is through using the limit and the average gradient. The combination of the limit and the average gradient to find the gradient of the tangent to the curve. Later on, after we've learned about the differentiation laws, then that other stuff comes into play. So I'm just building up from the beginning the concept. Okay. Anyways, I think maybe we can call it a day for today. Let me just do this one. Of course, this is applying the concepts we've learned, not so much the use of the differentiation laws, because we haven't got there yet. We will get there though, because we want to get everything in. So first things first, we know that the formula is the limit, so the gradient of the tangent is equal to the limit h approaches 0 of f of a plus h minus f of a over h. So f of a is going to be equal to f of 2, which is equal to 2 into 2 squared minus 5, which gives us 8 minus 5, which is 3. Hi man. Then f of a plus h is equal to f of 2 plus h, which is equal to f of 2 into 2 plus h, the whole thing squared minus 5, which will give us 4 plus h squared plus 4h, 8 plus 8h plus 2h squared minus 5, 2h squared plus 8h plus 3. Once we've got an f of a, which is 3, and f of a plus h, we can go now and say the limit h approaches 0 of f of a plus h. We substitute 2 into h squared plus 8h plus 3 minus 3 over h. Then We add like terms. Sure, the rain is crazy outside there. Wow. We factorize in the numerator. We cancel. So the gradient is equal to 8. So the gradient of the tangent to the curve f of x is equal to 2x squared minus 5 is 8. Okay. Yeah, hopefully that's clear. Okay. Yeah. So hopefully the concept is clear, guys. Concept is clear. Determine the gradient of k of x is equal to negative x cubed plus 2x squared plus 1, and point x is equal to 1. So I think we get the point, right? I think the concept has been explained to fruition. So remember, guys, this is just us using the idea of average gradient together with the limit to find the gradient at a point on a curve, the gradient of the tangent to the curve at the point that is given. Okay. Yeah, I think I'm gonna hold it right there for today. Okay, I'm gonna hold it right there. Then tomorrow, same time, we can do it like that. Tomorrow, same time. I'll then pick up from where I left off. We will do differentiating using first principles. I'll explain the concept. Shortly thereafter, we'll go ahead and do differentiation laws and the rules. Yeah, and then we'll look at other aspects. Well, actually, not tomorrow, today. Sorry, I've forgotten that we are actually obviously in today already. Okay, thank you so much. Have a great one. Let me love and leave you. Thank you for joining the live. It was much appreciated. Show white rose. The rose that was white and not red. Yeah, I'll leave you with this problem. Determine the gradient of k of x is equal to negative x cubed plus 2x squared plus 1 at point x is equal to 1. Yeah. Enjoy school. Enjoy school. Bye.